Okay, here we go. So welcome to 2 viewers. We were up to 3 a second ago, so hopefully that number will go up a bit. And hopefully a few more people watching it, not live, but afterwards. I've had a special request to help out a bit with some work I set on the iMaths for MYP3. I also set some of this for MYP2 as well, and also I went through some of this in a previous session. But what I'm going to do today is run through everything I've set for the week for MYP3. And it's useful, interesting to people in other age groups as well, because above MYP3 you still need the same algebra skills, and below MYP3, well, you should be able to sort of follow it along and get a sneaky preview of what you might be learning in the future. So first exercise it's the factorizing linear expressions exercise. Factorize these expressions. So just to recap about what factorizing is, let's just get the big pen for this. So if you see a number multiplied by something in brackets, so 5 in front of 3 plus x, so that's a multiplication. That means 5 times the whole of the bracket. So if you want to write that without the bracket, it's 5 times everything in the bracket. So 5 times 3 is 15. 5 times x is 5x. It might be something with algebraic terms inside and outside the brackets. So it could be something like 5x times, then this bracket that has 3x plus y in it. So then that would be 5x times 3x makes 15x squared. The 5 times the 3 is making the 15, and the x times the x is making the x squared. And then plus 5x times y makes 5xy. So that's multiplying brackets out, but factorizing is the reverse of that. So it's where we try to get from a multiplied out expression, if you like, and put it into a form that is several things, several factors multiplied together. So it's just the same process in reverse, and then I'm going to go through these questions and then hopefully explain my thought process in how I get to where I get. So the first one on my sheet, and remember when you do iMaths, you won't necessarily get the same questions. I think I will go for this pen. Okay, so 25a, just check we can see that. Yeah, that's visible. So 25a plus 35. We need to factorize that. So first of all, I need to think of something that both of these terms can be divided by. And they can both be divided by 5. So 5 is the number that I can take outside the brackets. And then I'm going to say that this thing here that I started with is equal to 5 times something in brackets. So we're trying to take out as much as we can, find the biggest number that goes into both of those. And in this case, it is 5. So then I'm asking myself the question, what have I got to multiply the 5 by inside the brackets in order to get the 25a? So 5 times what will give me 25a? Well, 5 times 5 will give me the 25. And then you need an a there, so that 5 times 5a will give me the 25a. And then I'm asking myself the question, 5 times what in the brackets will give me the 35? Well, 5 times 7 is 35, so that needs a 7 in the brackets. So the factorization is 5 times 5a plus 7. Okay, so on to the next one. I'm really not sure what pen to go with. I like the thicker one, but it's wearing it out a bit. It might not last the session. Anyway, we'll go with it. 6b minus 10 is the next one. So I need to think of something that 6b and 10 can both be divided by. Well, they can both be divided by 2. And 2 is the largest thing I can think of that divides them both. So I'm going to have some brackets with a 2 in front of them. And then I'm going to ask myself the question, 2 times what in the brackets will give me the 6b? So 2 times 3 will give me the 6. And then I need an extra b there, so that 2 times 3b will give me the 6b. Then I need to ask myself, what inside the brackets, when I multiply it by the 2 that's outside the brackets, will give me the, it's not a 10, but it's a minus 10. Because whenever you see a minus, it belongs to the thing that comes next. So what inside the brackets, 2 times what will give me minus 10. So that's minus 5. So the factorization is 2 brackets 3b minus 5. On to the next. So I'll get to the end of this block and then I'll look and see if there are any emails requesting other specific stuff. But I'm going to go through all of these today. Some of them are quite complicated and, to be honest, a little bit above the level in terms of how challenging they are. But we'll go for it. Okay, next one, 48 minus 6c. So both 48 and 6 can be divided by 6. So I can take a 6 outside the brackets, and then I'm saying 6 times what inside the brackets will give me 48. So the answer to that is 8. 6 times 8 makes 48. And then 6 times what inside the brackets will give me minus 6c. So I'm going to need a minus there. I'm going to need a c there. So 6 times minus c inside the brackets will give me minus 6c when I multiply those brackets out. So that's number 3. 3 down, 5 to go on this block. Just check it's all visible here. Okay, so the next one I've got is 9a plus 45b. 9a plus 45b. Well, 9 goes into 45, so I can divide both of these things by 9. So I'm going to take 9 outside the bracket. And then I'm asking myself the question, 9 times what in the bracket will give me 9a? So that's got to be an a. 9 times a will give me 9a. And then 9 times what in the bracket will give me 45b. Okay, well, I'm going to need a 5 there to make the 45. 9 times 5 makes 45. But then I'm going to need a b there as well. So 9 times a plus 5b is the factorization of 9a plus 45b. And you can always check these by just multiplying them back out and reversing it to the original question. Okay, the next one, 4p plus 12q plus 8r. So 4 and 12 and 8 can all be divided by 4. And that's the biggest thing that they can all be divided by. It's not going to be any bigger than 4 because the first term in this is just 4p. So a 4 is going to go outside the bracket. And then I'm asking myself the question, what do I need inside the bracket so that when I multiply it by the 4, I'll get the things on the left here. So 4 times what will give me 4p. That's p. 4 times what will give me 12q. Well, I'm going to need a 3 there to give me the 12. So 4 times 3 is 12. And then I'm going to need a q there as well to give me 12q. So 4 times 3q will give me 12q. And then finally, 4 times what inside the bracket will give me 8r. So 4 times 2 will give me the 8. But I want 8r, so I'm going to have an r there. And 4 times 2r gives me 8r. Swig of coffee. Throat getting dry. Number 6 on that block. 50a minus 20b minus 10c. Oh, now I'm annoying myself because I haven't left myself enough space to line up my equal signs vertically down the page. So that is a little bit frustrating, but never mind. Okay, so the biggest thing that all of these divide by, well, in fact, they all divide by 10. And there's not going to be anything bigger than 10 because the last one just has a 10 in it. So I'm going to take a 10 outside the bracket and say 10 times what inside the bracket will give me 50a. So 10 times 5 will give me the 50, but I want 50a. So 10 times 5a will give me the 50a. Now I need to ask 10 times what will give me, and remember this is a minus 20b because the minus belongs to the 20b. So 10 times what will give me a minus 20b. Well, I'm going to need a minus 2 there because 10 times minus 2 will give me the minus 20. But then I'm going to need a b there as well, so that 10 times minus 2b makes minus 20b. Okay, the last term of that, 10 times what in the bracket will give me minus 10c. So that's going to be minus c. 10 times minus c is going to give me minus 10c. So that's the factorization for that one. Question 7 of this. 10p plus 14q plus 4r. Okay, so I see that 4 goes into 4, obviously, but 4 doesn't go into 10 or 14, so 4 is too big. In fact, the biggest thing we can divide everything by here is 2. So I'm going to take 2 outside the brackets. 2 times what will give me 10p. So 2 times 5 will give me 10, and 2 times 5p will give me 10p. 2 times what will give me 14q. Okay, so 2 times 7 will give me the 14. So 2 times 7q will give me the 14q. And then finally, 2 times what will give me 4r. So 2 times 2 will give me 4, and 2 times 2r will give me 4r. Okay, one more to go of this block. Just checking it's all visible on screen. Yep, 25s. Trying carefully not to make my s look like a 5. 25s minus 25t. Oh, so 25 could go into all of these. But then the last term, 45u, so 25 doesn't go into 45. So in fact, the biggest thing that goes into all of those is 5. So I'm going to have to take a 5 outside the brackets and say 5 times what will give me 25s. So 5 times 5 will give me the 25, and 5 times 5s will give me the 25s. Next one, we've got a minus here, minus 25t. So 5 times what in the brackets will give me minus 25t. Well, 5 times minus 5 will give me the minus 25. And then I just need to stick a t on the end of that so that it's 5 times minus 5t will give me minus 25t. And then the last term, 5 times what will give me 45u. Okay, so 5 times 9 will give me 45. So 5 times 9u will give me 45u. So that's that block dealt with. If you didn't follow along at the speed that I did it, you can always watch it afterwards. All these videos are staying up on my channel. Let's go for a new sheet. Just going to check for any emails I might have got. Okay, so I've got a couple of emails. So I've got one from mystery student in MYP4. Let's call him T, thanking me for my geometry solution that I did for him. Good. And then an MYP5. And on with the next block. So 3a squared plus 2ab. Now, what's different about this block on tab 2 of the factorizing linear thing is that it's not necessarily numbers that come outside the brackets, but it can be letters. So, for example, 3 and 2. Now, there are no common divisors of both 3 and 2, so there's nothing we can divide it by in terms of regular numbers. But they've all got things with, or they've both got things with a in them. So I've got an a squared there, and I've got an a there. So certainly I could divide both of those by a. We don't know what a is yet. It's just an unknown quantity, but we can still manipulate it in the same way as we did with numbers. Okay, so A comes outside the bracket. Then I'm asking myself the question, A times what inside the bracket will give me 3A squared? Okay, well, A times another A will give me the A squared. But then I've got 3A squared, so I'm going to have to stick a 3 in front of that. And A times 3A makes the 3A squared. Then I'm asking myself, what inside the bracket, when I multiply it by A, will give me 2AB? Okay, so A times B will give me AB. And if I stick a 2 in front of that, A times 2B will give me 2AB. Remember when you're multiplying that 2B times A and 2A times B mean the same thing. So the fact that it's the order that these things are in, the 2, the B and the A, doesn't necessarily matter. Although it's convention to write these things with the numbers first and then the letters in alphabetical order. So you might think that A times 2B should be A2B in that order, but that doesn't go with the convention that mathematicians use. So not A2B, but 2AB, always with the number first, and then preferably with the letters after that in alphabetical order. Then we're all writing things the same way, and then we all get our solutions the same way. Okay, 7P. This pen is really struggling now. I might pop downstairs and see if I can find a new one in a minute. Okay, so we've got 7P, we've got PQ, so that's like having one PQ. We've got 6PR. So there are no numbers that all of these things divide by, but they've all got a P in them. So I can take a P outside the brackets and then say P outside the brackets times what inside the brackets will give me 7P. So that's going to be a 7. P times 7 gives me 7P, written as 7P and not as P7. And then P times what inside the brackets will give me PQ. So that's got to be a Q. And then P times what inside the brackets will give me, now remember that's a minus, minus 6PR. Okay, so I'm going to need a minus 6 there, and I'm going to need an R there. So 6 times minus 6R will give me the minus 6PR. And again, we've got that in alphabetical order, so that would be the same as minus 6RP if you wrote it in that order. But we're sticking to the convention of trying to put things in alphabetical order, so minus 6PR. So that's the factorization anyway. On to the next one. I'm going to try with a different pen, I think. Okay, so 8S, again trying to make my S not look like a 5. 8ST, can we see that? Just about. Plus 7SU minus 9SV. We want to write as something times something in some brackets. Let me just draw a line there away from my rough stuff. Okay, so there are no common factors of 8, 7, and 9, so there's no number we can divide them all by, but they've all got an S in them. So S times what inside of the brackets will give me 8ST. So I need to multiply that by the 8 and the t to get the 8st. And then s multiplied by what inside the brackets will give me 7su. So it's going to need to be multiplied by the 7 and the u, and s times 7u will give me the 7su. And then I've got a minus term here, minus 9sv. So s times what will give me minus 9sv. So I'm going to have to multiply it by a minus 9 and also a v. So minus 9v inside the brackets for that one. Okay, I can see I'm losing viewers thick and fast. Oh, we just got another one. So back up to 3. Swig of coffee and on we go. Now the next ones start to get interesting because you've got more letters in them. I do think I need to find a better pen than this. I could go for just for the board and my big pen. Let's try that. Okay. So for P, is that the next one? Yes, that is the next one. 4p q squared plus 3qr plus 5p qr. Actually, this isn't so bad at all because I can write things directly underneath now. Okay, so all of these, that's got a p in it, that's got a p in it, but that hasn't got a p in it, so I can't take the p, so to speak, out of the brackets. 4, 3, and 5 don't have any common divisors, so I can't take any numbers outside the brackets. But all of these have got at least one q term in them. So I can take a q outside the brackets and then say q times what gives me the term I started with. So q times what inside the brackets will give me 4pq squared. So I'm certainly going to have to multiply it by the 4 and the p. And then I want a q squared there. I've got a q, so I'm going to have to multiply it by another q to get q squared. So 4pq times another q gives me 4pq squared. Okay, the next one. Q times what inside the brackets will give me 3qr. So I'm going to need to multiply it by 3. The q's already there, and I'm going to multiply it by r. So q times 3r gives me 3qr. And then the last bit, so I'm trying to get 5pqr. So q times what will give me that? So I need to multiply it by the 5. I need to multiply it by the p. I don't need to multiply it by anything to get a q because there's a q already there. And I need to multiply it by an r. So that q times 5pr gives me 5pqr. Okay, that's that one. I think I need to tick these off as I do them to keep track of them. The next one's super interesting now because it's got 2 different letters that are going to come outside the brackets. So let's just see if that works. Okay, so I've got 6a squared b plus ab squared minus 6ab. So 2 of these terms have got a 6 in, but the other one hasn't, so we can't divide by 6. They've all got at least an a in them. Some of them have got an a, some of them have got an a squared, but they've all got at least one a in them. So we can take an a outside the brackets. Furthermore, they've all got at least one b in them. So this one's got a b, this one's got a b squared, This one's got a b. So we can take a b outside the brackets as well. So the objective when you're factorizing is to try and take as much outside the brackets as you can, because well, it's a little bit abstract at the moment, but when you get to further algebra, you will find that having things factorized as far as possible can help you solve equations. Anyway, so AB times what inside the brackets will give me 6a squared b. Well, I need to get 6 somewhere, so I've got to put 6 there. I need to get an a squared, so the a outside the brackets will need to be multiplied by another a to get the a squared, and then b, we don't need to do b because multiplying by b here, and we're only trying to get a single b, so 6a times ab will give us 6a squared b. We've got the 6, we've got the a times a giving us the a squared, and we've got the b giving us the b. So that's the first term. Okay, ab times what inside the brackets will give us ab squared. So we need to multiply that by another b to get the b squared. And that's that term. And then the last term, ab times what inside the brackets will give us minus 6ab. Okay, so we need the minus 6 there. And then we've already got the a and the b. So minus 6 times ab will give us the minus 6ab. So that's that one. 3 viewers. I imagine there will be quite a few watching this afterwards on the replay when they all get stuck on the homework. But good if you can watch it live, and then you can just throw any queries at me while you think of them. I don't need to tell you if you're watching live, do I? Okay, the next one, 6t squared u squared plus 8t u squared v plus 7t u w. Wow. Okay, so it looks daunting because of all the letters, but the process is the same every time. So that's equal to, okay, so 6, 8, and 7 haven't got any common factors, so we can't divide by any numbers. All of these have got at least one t in them. So that's got t squared, that's got a t, that's got a t. So we can certainly take a t outside the brackets. They've all got at least a u in them. So that's got a u squared, that's got a u squared, and that's got a u. So I can take a u outside the brackets. Some of them have got v's and w's, but not all of them. So the biggest thing that all of these can be divided by, that, and that, is tu, t times u. So now I'm back to the brackets and trying to fill the brackets in with things that will multiply by tu to get what I started with. Okay, so tu times what inside the brackets will give me 6t squared u squared. Well, I'm obviously going to need 6 there. I'm going to need to multiply the t by another t to get the t squared. And I'm going to need to multiply the u by another u to get the u squared. So that's that term. Then I'm asking myself, tu times what inside the brackets will give me 8tu squared v. Obviously, I'm going to need an 8 there. I don't need to do anything with t because there's a t there and I've already got a t. But then I'm trying to get a u squared, so I'm going to need to multiply the u that's there by another u to get the u squared. And then finally, I want that v on the end, so I'm going to have to multiply the whole thing by v. So the next term is 8uv. Then the next term, so tu times what inside the brackets will give me 7tuw. So obviously, I'm going to need a 7 there. I've already got the t and the u, and I'm going to need to multiply that by that 7 by w as well in order to get the w on the end there. So tu times 7w gives you 7tuw. Just remember again that, tu times 7w, you might think it looks like that, tu7w, but when you are multiplying, the order doesn't matter. So t times u times 7 times w is the same as t times 7 times t times u times w. The order doesn't matter, but you do try and stick to a convention of putting the number first and then the letters in alphabetical order if possible, so that everybody's writing everything the same way and it looks a whole lot neater. Okay, so that was that one. 2 more on this block. 3 viewers. 3 viewers live. I bet there'll be about then guess. I bet there'll be 35 views by the end of the day. Okay, 12AB. Oh, this is a long one. 12ABC squared minus 28A squared BC plus 12AB squared C. So that's quite a tricky one, and it's a level above because on this occasion both numbers and letters come outside the bracket. So 12, 28 and 12 again can all be divided by, well, they can all be divided by 2. They can all be divided by 4. 28 is 4 times 7. 7 is a prime number which doesn't go into 12. So the biggest number you can divide all of those by is 4. Then they've all got a's in them. That's got an a, that's got an a squared, and that's got an a. So we can take an a outside the brackets. They've all got at least one b in them. So I can take a b outside the brackets. And they've all got at least one c in them. So I can take a c outside the brackets. So all of the terms in this can be divided by 4abc. So now I'm asking myself the question, 4abc times what inside the brackets will give me 12abc squared. Okay, so I'm going to need to have a 3 there so that I get the 4 times 3 is 12. I've got the a, I've got the b, but then I'm trying to get a c squared. So I'm going to have to stick a c there so that c times c squared, c times c will give me the c squared. Okay, so that's the first term. Then I'm asking myself the question, 4abc times what inside the brackets will give me the, remember that's a minus 28a squared bc. So I'm going to have to multiply it by, going to have a minus 7 there so that I get 4 times minus 7 gives me the minus 28. I've got an a there, but I want an a squared, so I'm going to have to multiply it by another a to get the a squared. And then I've got the b and the c, so I don't need to do anything with those. So 4abc times minus 7a will give me the minus 28a squared bc. I know it's hard to follow along. It's a lot of letters, but the principle is the same for all of them. Okay, now I'm trying to get 12ab squared c. So 4 times 3 will give me the 12. I don't need to do anything with the a's. the b's, I've got a b, I'm trying to get a b squared, so I'm going to have to multiply that by b to get the b squared, and then the c's are as they should be. I've got a c, I don't need any more c's. So the full factorization is that the thing we started with is equal to 4abc outside the brackets, and then in the brackets 3c minus 7a plus 3b. Okay, I can see I've actually had a message coming in. Oh no, that's just thank you for helping. Oh, good. That's always nice to hear. Okay, so I will just do the last one. So don't worry if you were copying something down and you missed it, because you can play this back after. Okay, so the last one on that block is 50 PQRS, goodness, plus 20 Q squared RS minus 70 QRS equal to something outside times a bracket. Okay, well 20, 50 and 70, they all divide by 10. So I can take a 10 outside the bracket. They don't divide by anything bigger than that. There's a p in there, but these haven't got any p's in, so I can't take the p, so to speak. They've all got a q in, so I can take a q outside. They've all got an r in, so I can take an r outside. And they've all got an s in, so I can take the s outside. Can I take a swig of coffee? No idea what the time is. 12:39. Right. So I doubt whether we'll get through everything here, but we can. I can post something up later, or we can. We'll see how we go. Okay, so 10 QRS times what inside the bracket will give me 50 PQRS. So I'm going to need to multiply it by 5 to get the 50. And I'm going to need to multiply it by P to get the P. Next one. 10 QRS times what inside the bracket will give me 20 Q squared RS. So I'm going to need to multiply it by 2 to get the 20. And I've got a Q, but I want a Q squared. So I'm going to need to multiply it by Q to get the Q squared. And then the R and the S are already there. And then the last term, 10 QRS times what inside the bracket will give me minus 70 QRS. So remember, minus belongs to the thing that comes next. So 10 times minus 7 will give me the minus 70. And then the QRS are already there. So that's just a minus 7 on the end. So the factorization is 10 QRS brackets 5P plus 2Q minus 7. Wow, this is hard work on my voice. Just a solid hour of talking. It's more than I usually talk in a month. Okay. So now we're off factorization and we're talking about rearranging equations. So I think I'll just stick to the big board for all of these now. So x minus y equals w. And I want to rearrange that into an equation that says x equals something. So making x the subject. So I'd like to get the x on its own. I need to get rid of the minus y. I get rid of a minus y by adding y to cancel it out, and it disappears. But because an equation is like a balance, when I add y to the left, I also have to add y to the right. So x equals w plus y. And that's the first question answered, because that's what we're trying to do. We're trying to rearrange them as x equals something, something, something with all the other letters. That's that one. Next one. I've got x plus 5y equals 6v. I'm trying to get the x on its own, so I just take away the 5y bit to get the x on its own, and it disappears. But because an equation is like a balance, I've got to take away 5y the other side as well. So x equals 6v minus 5y. Once again, that's the final answer. That's all we needed to do. Just got to write it as x equals something involving all the other letters. I'm going to skip the next two because they are as easy as the first one. And I'm going to go to this one with a big fraction in it that says x over v minus w equals y. Now, whenever I see a fraction, I'd like to get rid of it. So I'd like not to have x divided by v minus w, but just like a big old x on its own. So to get rid of the fraction, I need to multiply by the thing I'm dividing by, which is v minus w, which I'm going to put in a bracket. So I'm multiplying by the whole of v minus w to get the x on its own. But because an equation is like a balance, if I multiply the left by v minus w, I've also got to multiply the right by v minus w so that it still balances. So x is equal to y brackets v minus w. And, you know, we've just seen from the previous exercise about factorizing and multiplying out what that means. It means y times everything in the bracket. Okay, that's that one. Next one. Next one's super tricky because it's got two fractions in it. V over 5x equals w over y. It's tricky because it's got two fractions in it, and it's tricky because the x that we're trying to get there is at the bottom of the fraction. So what I'm going to do here is try and get rid of the fractions by multiplying by the denominators. So if I want to get a whole v here to get rid of this fraction, but to do that I'm going to have to multiply by the 5x to get rid of the fraction. So I've multiplied by, let me just tidy that up a bit. Multiplied by the bottom of the fraction, the 5x, the denominator, to get a whole v. But if I'm multiplying the left by 5x, then I need to multiply the right by 5x as well. So instead of w over y that was already there, I'm going to multiply that by 5x and get, let's go for a different color here, get 5x w over y. You know what? I'm going to put all of my 5x's here in red just to try and make things a little bit clearer. And at this point, I wish I had a third color pen. I've got 10 million green pens at school, but not allowed in school. Okay, so I've multiplied everything by 5x to get v equals 5xw over y. I've tried to stick to the convention here of having the numbers first followed by the letters. And that's got rid of one of the fractions. I'd like to get rid of this other fraction. So I've got v equals some or other stuff here divided by y. I'd like to get rid of that fraction. I'm going to multiply by y. And then when I multiply by y, I just get the top bit, the 5xw. But for that to still balance, I've got to multiply by y the other side as well. So instead of v times y. I've tried to keep that in alphabetical order, so v times y rather than y times v, although it wouldn't really make a difference. Okay, v times y equals 5 times x times w. I am trying to get the x on its own, and I can get the x on its own if I divide by the 5 and the w. So divide by 5w, x is equal to, I've got to do the same the other side as well. So the y that I had divided by the 5 and the w, divided by 5 and the 5w, and that gives me the final answer because I've got an expression that has x equals something with all the other letters. Then the only other thing I ought to do with that is to just write it the other way around. Don't know if I've got enough space here, but x equals the x first equals the other thing is the way we want it written down, because that's the answer to the question. And you normally have the thing you're trying to get on the left equals whatever you figured it out to be on the right. Okay, so that was tricky, wasn't it? And pause the video, obviously, if I'm going too fast. Play it back afterwards. Yeah, you can't pause it if it's live, can you? Or can you? Can you pause it if it's live? I suppose you probably can. Anyway. Okay, it's now nearly 10 minutes to 1 and 2 viewers out there still. So I think I'll carry on with the rest of the last couple of questions on this sheet. Vx plus W equals 3. Okay, so I'm trying to get the x on its own. So I'd like the bit that's got the x with it on its own first, and then it's easy to get rid of the w by taking away w. But then I need to do the same on the right as well. So Vx equals 3 minus w. I don't want to know what Vx is. I want to know what x is on its own. So I'm going to divide everything by the v. But if I divide the left by v, I've got to do the same on the right as well. So I get what I had before divided by v, and x equals 3 minus w divided by v. Okay, that's that one, and we'll rub out. I've got 3w plus vx equals y as the last one. Okay, so I'm trying to get the x bit on its own. So the bit that's got the x in is the vx. So I'd like to get rid of the 3w plus 3w there. So I'm going to take away 3w to get the bit with x on its own. But then I need to take away the 3w from the other side as well for it to balance. So vx equals y minus 3w. I don't want to know what vx is. I want to know what x is on its own. So I'm going to have to divide that by v to get the x on its own. But because an equation is like a balance, whatever I do to one side, I have to do exactly the same to the other side. So I'll divide the other side by v as well. I get x equals y minus 3w divided by v. Can you hear my voice going? Okay, so that was block 1. Block 2, a little bit trickier, brackets involved, different ways of writing the answer. Yeah, so you'll certainly want some help with that. I did do one of them, I think, the other day, but let's do a couple of these before we hit 12 o'clock. 1 o'clock. No more mails there. Just check that. Okay, so I've got A. Can you see that red? No, I think I'll stick to the blue. A brackets x plus b equals c. And you've got to rearrange that as x equals something, something, something with the other letters. Okay, so yeah, you will need a little help with this. That I've not done much in class, but the thing to do here is multiply the brackets out. So a times x gives me ax. A times b gives me ab. So that bracket is the same as ax plus ab equals c. Now what we're trying to do here is get the x on one side and all of the other stuff on the other side. So at the moment I've got an ax and then something that doesn't have x in it at all, ab. So if I take away that ab bit that doesn't have any x in it at all and just leave the bit with the x in on its own, so I'm taking away ab from both sides, but because it's like a balance, I've got to do it on the right as well. So ax equals c minus ab. Now, I don't want to know what a times x is. I want to know what x is on its own. So I'm going to have to divide it by a to get the x bit on its own. But because an equation is like a balance, I need to do exactly the same on the right-hand side as well. So I need to divide the right-hand side by a as well. And that gives me an answer. X equals c minus ab, all divided by a. Now it says there are two ways to rearrange each equation. So there are two sets of answer boxes. You only need to fill in your answer once. Okay, so for this one, I'm going to fill it in in that space there. But I could have written that as two separate fractions. But I'm going to right. So for example, this one, c minus ab over a. I could have written it as two separate fractions, ca minus c over a minus ab over a. So just split it up into two separate fractions, both over a. And then I might have spotted that writing it like that in the second fraction, a on the top and a on the bottom cancel. So that's the same as having ca minus b. So here, where they've got two alternative ways that they allow you to write the answer, those are the two alternative ways for this question. But in any case, you don't need to write it both ways to get the mark. You only have to do it one way. Yep, you only need to fill your answer once. Okay, I think I'll just do one more of those, and that will take us up to 1 o'clock. And then which one shall I do? Shall I do the last one, or shall I do the one with the minus in? Let me just think about that. I'll do the one with the minus in. Okay, so a brackets x minus 4 equals b. So remember, we're trying to rearrange this as x equals something, something, something with all the other letters. So I've got a times all this stuff in a bracket equals b. I'd quite like to have this stuff in a bracket all on its own because it's got the x in it. So I'm going to divide everything by a, and then I just get the bracket on its own. But because an equation is like a balance, I need to divide the other side by a as well. So x minus 4 equals b over a. Now actually I don't really need those brackets there at this stage. I needed them before to show that the a was being multiplied by everything in the brackets, but now that I've got rid of the a, I can just write that without the brackets. So x minus 4 equals b over a. I don't want to know what x minus 4 is. I want to know what x is on its own. So I'm going to add 4 to get rid of the minus 4. But because an equation is like a balance, I need to add 4 the other side as well. So b over a plus 4. So x equals b over a plus 4 is a perfectly acceptable final answer. If I wanted to write that the other way as a single big fraction, then what I would have to do is say, okay, so b over a plus 4 is the same as b over a plus 4 times a divided by a. So I kind of multiplied by a over a, which is just like multiplying by 1. And the reason I've done that is so that now I've got two separate fractions and they've both got the same denominator. So I can just write that as one big fat fraction, b plus 4a, all divided by a. So that's another acceptable alternative form for the answer. Although generally speaking, in exams and things, don't go offering alternative forms for answers, because if you mess one of them up, you might end up losing all of the marks. Okay, well, that very nicely takes us to 1 o'clock. We didn't get onto rearranging 2 from my iMaths, so I think I will do that one first on Monday, perhaps. If I'm feeling energetic, I might put it up as a separate video, but no promises made there. And then do continue to send requests about specific things that you're stuck on, and then I can go through the exact things that you need particular help with. Okay, so that's 1 o'clock just about. So that's that for the day, and we will be back on Monday at 12 o'clock. And then next week, so I'm going to try to get setting work on ManageBack that kind of better fits the daily schedule. So rather than one block for the whole week, more sort of day by day. So we'll see how we go with that, and do get in touch with your questions.